What's up, guys? In this video, we're going to be taking a look at some more laws of exponents. We're going to be continuing on to the lecture I showed you in the previous video, which was multiplying and dividing exponents with the same base. And I've left the link in the description below so you guys can check it out as well. So without further ado, let's get to this lecture now. So in this lecture, we're going to look at power raised to a power. So what does that mean? So for example, a to the power of x, okay, and then we've put that in brackets here, which means a to the power of x, and then you see two exponents here. So now we have a situation where we have two exponents. So we are raising this first one number to the power of x, right? And then that result, we are raising it to the power of n. So we're dealing with two powers right now, two exponents. So this is a power raised to a power rule. So of course, as I said earlier, let a represent any real number, which means any number in this case. And as I said in the last video, x and n, they apply for all types of exponents, whether it be positive integers, negative integers, negative exponents, fractional exponents, which we'll take a look at soon. So they apply for all. So basically x and n also represent any real number. So just to make that clear, so now we'll look at an example. So 3 squared, okay, squared again. So we have two different powers now. So it doesn't have to be the same. The powers, see how x and n are two different, they represent two different numbers. So the exponents don't have to be the same for this rule to apply. I'm just using this example for you guys to understand it, but this exponent does not have to, exponents do not have to be the same. This rule will apply for, even if this was 3 squared to the power of 3, then the rule I'm going to show you right now applies. So just to make that clear, so let's solve without the laws of exponents. So 3 squared. What is that? So since the brackets are here, bedmass, we have to do what's inside the brackets first. So 3 squared is 9. Okay, so we have our result. 9 squared equals 81. Okay, so that is 81. So what does the laws of exponents say? So when a power is being raised to another power, we multiply the exponents. So notice how in the last video we added the exponents when we were multiplying two exponents with the same base, and subtracting when we were dividing exponents with the same base. So right now we're doing the next step, which is multiplying. So when we have one base, something like this, one base raised to two different exponents like this, or like this example, we multiply the exponents. So when we're raising them, we multiply the exponents. So when power is being raised to another power, like this, we multiply the exponent. So look at the same example right now. So remember that the answer for this was 81. So just multiply the exponents. So we have 3. And we have, as illustrated here, we have two different exponents. We have an exponent being raised to another. We have one base and then two exponents. So the base being raised to one exponent, and then that result being raised to another exponent, as indicated by the brackets here. So that being said, we can use this rule here. And they could be same. The two exponents could be same, like this example, and they could be different. That's why I put x and n. So they could be two different in numerical values. In this particular example, they're the same, but just to make things clear, the rule applies for all kinds of situations where you have this. So multiply the exponents. So we have our base. So what is multiplying our exponents? So our exponents here are 2 and 2. So 2 times 2, 4. So 3 to the power of 4. 3 times 3, 3 times 3 times 3 times 3. So if you want me to do it step by step, since it's only 4 numbers, 3 times 3, 9. 9. 9 times 3, 27. 27 times 3, 81. So 3 to the power of 3 to the power of 4 gives you 81. So that proves that this rule is correct. So basically, when a power is being raised to a power, like this particular example, like similar to this, we multiply the exponents. Okay, so let me show you a few more examples, and then we'll move on to the next laws of exponents. So let's see. All right, so here we have another example. So I just use -2. Since the negative's inside the bracket, we are taking the square root of, sorry, not the square root. We are -2. We are raising it to the power of 2. And then if the negative was outside the bracket, like I said in my other videos, then we would have to 2 squared times -1. But since it's inside, we don't have to. We are taking a -2 squared now. So let's do it without the rule first. So as we know, we have one base, we have 2 exponents. So we're raising -2 to the power of 2 first, and then we're taking that result and then we're raising that to the power of 3. So -2 squared, we got 4. 4 to the power of 3. 4 times 4, 16. 16 times 4, 64. Just to show you guys how I got that. 6 times 4 is 24. 4 times 1, 4. 4 plus 2. 2 comes from here, 24. 6, 64. So 4 cubed, or 4 to the power of 3, or 4 raised to the power of 3 gives me 64. So now let's use our laws of exponents now. So -2, we have one base. Now, since as per our laws of exponents, we'll multiply the exponents since we have one base and 2 exponents. -2, right, to the power. Now, what is 2 times 3? Our 2 exponents are 2 times 3. So what is that? -2, 2 times 3. -2 to the power of 6. And that would be -2 times -2 times -2 times -2 times -2 times -2. So it continues like that. So that's 4. 4 times -4, -8, 16, -32, -32, which is -2 to the power of 5. So -2 to the power of 6 would be positive 64. And if you notice here, both of them are correct. Both of them give us 64. I mean, I did this without the laws of exponents with my knowledge of BEDMAS, but in this case, I'm using the laws of exponents and multiplying the exponents. And this here, if you can't see it properly, I'm just multiplying -2 by itself 6 times, as indicated by the exponent, because it goes down like this. So the answer gives me the same. So in that case, that concludes this lecture. So power raised to a power, when you have something like this, all we're doing here is we're multiplying the exponent. So the base stays the same, we're just multiplying the 2 exponents. So power raised to a power, and that is that for you. So in the next lecture, we'll be continuing on with the laws of exponents. We'll look at raising a fraction raised to a power, product raised to a power, and we'll go from there. So thank you very much once again, and we'll see each other in the next video.